Whenever you visit a doctor, the first thing he does is he places his stethoscope and he tries to hear something on your chest. So what is he trying to hear? Well, he's trying to hear the sound of your heartbeat. Blood flows from the atria to the ventricles. So there must be a pore present between the atria and the ventricles. So why do heart muscles need to contract? Blood could have easily flown out through the pore without the heart contracting. Well, if there were only pores, during ventricular systole, blood could have reverted back into the atria. This is not acceptable because blood has to flow unidirectionally in the body. To prevent the backflow of blood, the heart has several valves inside it. This valve present between the atria and the ventricles prevent the backflow of blood from the ventricles into the atria. And during ventricular systole, when the ventricles are pumping blood into these blood vessels, even these blood vessels are guarded by valves to prevent the backflow of blood. See, this is a top view of an apartment, and you can see doors which are hinged at one end and separates two rooms from one another. So you can easily compare these doors to the valves present in the heart. Now notice these valves that are present between the atria and the ventricles prevent the backflow of blood from the ventricles to the atria. Next, when the ventricles pump blood to these vessels, these valves prevent the backflow of blood from these outgoing arteries back to the ventricles. So these valves close the pores that are present between the heart chambers, and when the heart muscles contract, these valves open and the blood is forced out into the next part of the heart. During atrial systole, see, this valve opens to let the blood flow, and during diastole, its shut closes. This is because of the flexible nature of the valves. Since these two valves are present between the atria and the ventricles, they are known as the atrioventricular valves. So there are two atrioventricular valves present in the heart between the right atria and the right ventricle and the left atria and the left ventricle. During atrial systole, this valve opens to let the blood flow, and then during diastole, it shuts closes. When it shuts closes during atrial diastole, it generates a sound. This sound is lub. So, closing of atrioventricular valves causes the first heart sound, which is lub. The right and the left atrioventricular valves do not look similar. See, the right atrioventricular valves has 3 cusps. But the left atrioventricular valve has only 2 cusps. So the right atrioventricular valve is known as the tricuspid valve because there are 3 cusps present, and the left atrioventricular valve is known as the bicuspid valve because of the presence of 2 cusps. When the right ventricle and the left ventricle contracts, the blood flows into the pulmonary artery and the aorta respectively. Now both these vessels are present in the upper parts of the heart. So there is a huge chance of backflow of the blood into the ventricles. Well, to prevent that, these junctions between the right ventricle and the pulmonary artery and the left ventricle and the aorta is guarded by valves. See? The right ventricle and the pulmonary artery, at the junction of these 2 vessels are present this valve, and between the left ventricle and the aorta is present these 2 valves. See, these valves look like half moons, and that is why they are known as semilunar valves. Semi means half, and lunar comes from the word moon. Now, just at the end of ventricular systole, these semilunar valves shuts close to prevent the backflow of blood from the vessels back to the ventricles. And this shutting down of the semilunar valves just at the end of ventricular systole causes the second heart sound, which is dub. So the first heart sound was lub, which was occurring just at the beginning of atrial diastole because of the shutting of the atrioventricular valves. And the second heart sound, dub, happens just at the ending of the ventricular systole when the semilunar valves are shutting close. So, when a doctor places a stethoscope on your chest, this is what he is trying to hear. He is trying to hear the lub-dub sound of your heart. And by this sound, he is able to figure out whether your heart is pumping blood efficiently. When you run a mile, you can often hear rapid heartbeats. Well, when you run, your muscles are working a lot, so your body needs a lot of oxygen, and for that, the heart is pumping more and more blood so that your body gets enough of energy. So, when the heart is pumping a lot of times, it means that the rate of contraction and relaxation of the heart muscles are also getting quickened. And this is causing the heart sounds lub and dub because of the closing of the valves that are present inside the heart. So since the rate of contraction and relaxation or the heartbeats increase, the frequent sounds of lub-dub also becomes more. And that is the reason you are almost able to hear your own heartbeat.